to learn a new topic, the very beginning introductory topic of this nucleophilic substitution reactions. I shall say that this is not a new topic, but in fact you people have already educated yourself with this topic during your schooling. That in organic chemistry, majorly there are 4 types of the reactions. These reactions include, let us say, substitution, addition, elimination, and rearrangement. So there are total 4 types of reactions which are generally observed in organic chemistry. In organic chemistry, we cannot have a reaction which is different than this 4 out of reaction. Somehow it may be other kinds of reactions such as oxidation, reduction, or etc. So these are the reactions which are generally observed in these kinds of organic chemistry. So we are going to learn one of the reaction which is called as nucleophilic substitution reaction. The reaction driven with the help of nucleophile. Because as the name indicates, nucleophilic, so basically there should be some content of presence of nucleophile in the reaction which can promote such kind of substitutions. So here in this kinds of reaction we are going to touch upon majorly a type of reaction which is called SN1 and SN2. So these SN1 and SN2 reactions are more important, and majorly there are major 2 types of this substitution reactions. So friends, let us learn this. What are these SN1, SN2 reactions? How they differ from each other? What are the factors which control this SN1 and SN2 reaction? And how they are different from one to another. All these aspects of SN1 and SN2 we shall study in this session and the 4 future sessions going to come in the future. Let us first of all learn what is called a substitution reaction. We know that there are certain species which are having negatively charged electron or a lone pair of electron. So the charge of electron is negative and it is always in search of positively charged species such as this substance negatively charged species are termed as nucleophile. If we dissect this word nucleophile, so it contains 2 major words, nucleus and phile. The charge of the nucleus is positive because the nucleus contains proton and that proton is positively charged. So that's why such positively charged species are always, let us say, remain attracted towards the नेगेटिव चार्ज. सो इसीलिए उनको बोलते हैं जनरली न्यूक्लियोफाइल. And another contradictory this, there can be certain substance which is having positive charge, and that's why they are in search of negatively charged electron. in search of electron, so such species are termed as electrophile. Themselves they are negative, but they are in search of positive charge, so that's why they are nucleophile. If they are itself negative, positive, and searching of negative charge, so that's why they are termed as electrophile. So philicity is more important. In other words, I can say nucleophile have attraction towards positive charge. क्योंकि खुद का negative charge है. So positive has the attraction towards negative charge, and negative charge has attraction towards positive charge. So in this reaction, generally this nucleophile will react with alkyl halide. So it will form this product along with the removal of this halide ion. Now let us understand this reaction. What is happening in this reaction? Here, halide ion is removed, and the position of halide halogen is captured by this incoming nucleophile. Now here I wish to claim the formation of a new product through a new bond formation between this R group and nucleophile. Basically, nucleophile is symbolized as Nu. So, where the, let us say, carbon halogen bond in the substrate, but however, in the product, now it is carbon nucleophile bond. So we have formed a new bond at the cost of carbon halogen bond. So this species is living from this reaction. Now this halide ion is termed as basically this. I mean to say it is generally termed as this living group, where it is going to leave from the reaction. That's why it is living group. Now, so a nucleophile, which was a species having negatively charged, it reacted with alkyl halide, and after the reaction with alkyl halide, now it is forming a new product along with the living group. So this is living group, this is product, this is substrate, and this is nucleophile. So this is a reaction which involves heterolysis. Why? Because here a reaction undergoes bond breakdown, which is a dissimilar dissociation. One of the ion is getting negative charge, other may be getting positive charge. One of the species is taking the electron to form a new carbon nucleophilic bond. So that's why this is a reaction which is termed as, let us say, I can update to you that it is basically heterolysis. So with this, we are moving to the next slide, where I wish to focus that nucleophile is a species, and I am giving one example of nucleophile. This time this nucleophile is assumed it is OH minus hydroxide ion. So this hydroxide ion reacts with alkyl halide to form alcohol, and the living group is X minus. In other words, you can assume nucleophile has attack on alkyl halide, and then alcohol is formed and living group is relieved. So this is what generally a reaction of alkyl halide and hydroxide ion, basically termed as substitution. So what does we study why it is called nucleophilic? Because there is a role of nucleophile. Nucleophile is small. That's why it is nucleophilic. Why it is substitution? Because one of the group is substituted with other group. If you remember, in cricket there are not 11 but 12 players. But there is also called 12th player. That 12th player in a cricket team is not allowed to perform batting. But however, that 12th player can be the runner of injured player. That 12th player can perform the fielding in place of the existing tired और इंजर्ड प्लेयर. क्रिकेट में चोट लग जाती है तो जनरली बैट्समैन रिटायर्ड हर्ट हो जाता है, रिटायर्ड बाय हर्ट. 12th प्लेयर को बैटिंग नहीं मिलता है. तो 12th प्लेयर कैन गो ऑन द फील्ड, कैन परफॉर्म विकेट कीपिंग, दिस फील्डिंग, cannot do bowling, but yes, field is possible. The runner for the injured player can be possible, and that 12th player is basically termed as a substitute that is going to replace one player on behalf of other. Same way it may be applicable to hockey, football, or whatever the match is there. So that 12th player is termed as substitute. Our reaction is also involving such kind of substitution, जहां पे X की जगह पे OH आ जाता है और X खुद निकल जाता है, will be cleaved, leaving or departing. So friends, this is what called substitution reaction. Already some was there, but its position, its place will be displayed. It will be displaced, and incoming group will occupy its own place. And this is called substitution. किसी की जगह so and so, it is termed as, let us say, nucleophilic substitution. Nucleophile, alkyl halide, which reacts with each other to yield this alcohol and living group. So what is the nature of living group? This is more important. If a living group has a friendship with the carbon, then if the friendship is strong, it is difficult to break the friendship. But if friendship is weak, किसी के बारे में कुछ भी बोल के सुना दो, फ्रेंडशिप टूट जाएगी. दो फ्रेंड की फ्रेंडशिप है और किसी एक को पैसे दे के खरीद लो, तो फ्रेंडशिप तोड़ सकते हो. Similarly, the same philosophy is also applicable to this living group nature. That if the bond is weaker, we can break the friendship and can make a new bond. But if a bond is strong, we may not be able to break the bond. In substitution, the living group का जो bond attachment है, that should be weaker. वो वीक बॉन्ड होगा तभी आप उस बॉन्ड को तोड़ पाओगे और नया एटम, नया ग्रुप आप जोड़ पाओगे. इसलिए लिविंग ग्रुप का जो बॉन्ड है ना, वो वीक होना चाहिए. और वो बॉन्ड वीक होने के लिए जो लिविंग ग्रुप शुड बी अ गुड लिविंग, उसके लिए जो बॉन्ड है वो वीक होना चाहिए. एंड इट मस्ट बी a weakly basic molecule. Why weakly basic? क्योंकि it should be able to occupy the lone pair with itself. Covalent bond is a friendship between two atoms. When both the atoms are taking one electron from each other and they are making covalent bond. अब ये फ्रेंडशिप को हमें तोड़ना है तो क्या होगा कि ये जो दोनों इलेक्ट्रॉन है ना, वो कोई एक चुरा ले जाएगा. I mean to say, one of the atom will snatch both the electrons, will get negative charge and will behave as a living group. So weakly basic molecule should be able to do this one. And halide ions are one of the ions which are very weak basic. F minus, Cl minus, Br minus, I minus. So all they are basically negatively charged species, and this negatively charged species can occupy this electronic charge on its head much easily. इसीलिए जो substitution reaction है ना, is always possible with halogens. So friends, relatively weaker bases, halogen containing substances are a preferred choice for substitution reaction. So living group का nature that should be always weakly basic, because वो जो lone pair है तो उसके after living it will be there on its head, that should be easily able to occupy. Conjugate base की stability होगी तभी acid will be that much reactive, otherwise will not be reactive. Okay, so maybe in this sense also this can be correlated. Now we are going to, there are two types of substitution reaction, which one is called SN1, other is called SN2. First, let us start from SN2. Because SN2 reaction is a kind of easier reaction, which is easy to understand. थोड़ा SN1 is little tricky, little difficult to understand, इसलिए SN1 को बाद में पढ़ेंगे. पहले we will focus ourselves on SN1. So nucleophilic substitution reaction where SN2 reaction. These are the kind of the reaction where the rate of the reaction depends upon the concentration of alkyl halide and incoming nucleophile. So here, the rate of the reaction, the speed of the reaction, whether the reaction is fast or whether the reaction is slow. So that depends upon the concentration of alkyl halide and the OH minus. इसीलिए rate is directly proportional to concentration of alkyl halide and nucleophile OH minus. So that means rate of the reaction is directly proportional to these two species. And if we want to remove this directly proportionality, we can put the constant K in both of these species, CH3Cl, OH minus. In this reaction, where K is basically termed as rate constant. So this is applicable to, let us say, this as per the theory of rate law theory. In this reaction happens to be second order reaction overall, because the reaction is dependent upon the concentration of alkyl halide and the concentration of OH minus. So here it is 1, this is also 1, 1 plus 1, it will become 2. इसीलिए SN2 reaction में ये जो 2 है ना, that means it is second order reaction. S stands for, capital S stands for substitution, and capital N, which is little down as compared to S. You can call it as subscript. So that's why it is SN2. When we are writing SN2, we have to maintain this spirit of writing as capital. N is also capital, but N is little downward as compared to S. With though or S, both are same height, same altitude. And this is how written about SN2 reaction. So this SN2 reaction mechanistically is like this. This is a mechanism of reaction. So what do you mean by mechanism? Mechanism means step by step description of the reaction. When you heard this word in organic chemistry, so it means step by step description of the reaction. How the reactants are converting into the products. How the attack is possible and how the living of the same group is possible. Departure, incoming, so these things are described with respect to perfect step by step. So that is termed as mechanism. So let us learn this first. How this SN2 reaction is possible. The description of the same is presented on this slide. text form, and schematic representation is here on this slide. In this mechanism, a negatively charged hydroxide ion is the reactive species which promote the reaction. Hydroxide ion initiate the reaction. It initiate in such a way that it attack on positively charged carbon. How come carbon is positive charge? Because of the presence of the chloride ion. And we know that these chloride ions are having this electronegativity. And because of electronegativity, carbon will get partial positive charge, halide ion will get, this halide ion Cl will get partial negative charge. And this partial word, although why it is called partial? Although the bond is covalent bond, but it behaves as an ionic bond. That's why it is partially polarized bond. एक इलेक्ट्रॉन कार्बन की ओर से, एक इलेक्ट्रॉन फ्रॉम हेलोजन. There was a bond formation. But halogen is more electronegative as compared to carbon. So now both the electrons are remain attracted towards Cl, towards chlorine. So that's why there was a need to display partial positive and partial negative. એ બીજું કંઈ નથી, પણ જેને ગુજરાતીમાં આપણે ઠળિયાનો ઠ કહીએ. So that is delta positive and delta negative. This delta positive and delta negative, that is a motivational fact for hydroxide ion to attack. As hydroxide ion is negative, this positively charged carbon is the electrophilic center. OH minus is nucleophilic center. So this OH minus is attacking on positively charged species. And here you can see this red colored curly arrow. In organic reaction, there are many types of arrows. We have seen in some of the previous sessions. It can be a reaction arrow. It can be curly arrow to denote reaction mechanism. Or it can be single-headed arrow to denote free radical. These types of curly arrow, makadiyo, means bent, tilted. That type of curly arrows are meant for reaction mechanism. So OH minus will attack on positively charged species, and Cl, this will withdraw its electron, and that will form this transition state. Transition state, what are they? Transition state are totally imaginary, hypothetical states where bond formation and bond breakdown can be possible, where always bonds are which undergo breakdown and bonds which are being formed are shown with the help of dotted lines. Likewise, this carbon halogen bond is undergoing breakdown. Carbon oxygen bond is undergoing bond formation. So with respect to this is a bond formation, this is a bond breakdown. Just like we have never seen God, Allah, Khuda, Bhagwan, we have never seen, but we believe that they exist. Similarly, this transition state, nobody has ever seen, nobody has ever isolated till today. But this is just a hype, a hypothesis, or imagination that this can be the transition state. So that nobody has seen this one, इसलिए this is a sign which is used, which is not the hashtag of Twitter and Facebook or Instagram. It is not a hashtag. This symbol, खड़ा लाइन है, उसको बीच में से 2 बार काट दिया है. So it is termed as double dragger. And so that is the mechanism of this one, through this transition state. It is always drawn in this square brackets. So that means, what does this square bracket mean? Square bracket mean, no, but this is intermediate. It is not the reactant, it is not the product. It is only intermediate. And the symbol of double dragger, this symbol is condition applied. What is the condition? Nobody has seen it, nobody has isolated it. That is a condition. And finally, you know these products, alcohol and halide. And this is what actually called the reaction mechanism of substitution nucleophilic bimolecular reaction. Why it is called bimolecular? Because rate determining step of the reaction is this one, RDS. This is the attack of hydroxide ion and the departure of Cl minus. That is the rate determining step. And because of this only, this is a slowest step. There are 2 steps. एक तो है कि attack of hydroxide ion and दूसरा है departure of Cl minus. So this is easy. This is a slower step. But it is rate determining step. And in rate determining step, both the species are involved. You can call alkyl halide as well as OH minus. That's why this reaction is termed as second order reaction. Nucleophilic substitution bimolecular SN2. And in this reaction, the attack of OH minus and the departure of Cl minus both are happening simultaneously. एक का अटैक होता है, दूसरे का डिपार्चर होता है. So attack and departure. attack and departure. Both the phenomena are simultaneous, hand in hand. So that is occurring together. So इसीलिए this reaction is called, the mechanism of this reaction is concerted reaction, because bond breaking and bond formation both are occurring in a synchronized fashion together. Both are happening. એવું નથી, it's not like that एक बॉन्ड पहले बन गया, अटैक बन गया है, बाद में दूसरा बॉन्ड टूटा है. जितना जितना वो बनता है उतना उतना वो टूटता है. So that's why this reaction is SN2, concerted reaction. The mechanism of this reaction is synchronized manner will occur. In synchronized fashion, attack of OH minus, Cl का departure. Both happen simultaneously. So that is the reaction mechanism for this one. This is free energy diagram, a reaction mechanism diagram, where on x-axis the progress of reaction is plotted, and on y-axis the free energy of the reaction is shown. So with respect to this, we can see that reactants are having higher most free energy, and that transition state is even having higher energy. So the difference in the energy of reactants and transition state is termed as energy of activation. Free energy of activation, delta G, you can call it as a star or delta G, double dragger. Activation energy. The difference in the energy of the reactant and the difference in that of the energy of the energy of the transition state. But the product's energy is much less as compared to reactant. Energy of reactant थोड़ा above upper है, ये थोड़ा below है. So this is free energy change. What is delta G? Delta G is the difference in the energy of the reactants and of the products. But for energy of activation is a summation of the energy of reactants and that of the transition state. So slowly the reaction का जो energy वो बढ़ता है, it go on increases, and after the formation of transition state, जितना जितना product वो बनता है, energy down होती है, even that decreases as compared to that of the reactant. So this is basically a kind of parabolic curve for energy diagram or SN2 reaction. For methanol, formation of methanol from methyl chloride, you can see OH minus CH3Cl are the reactant. They have almost 103 kilojoule per mole. This much amount of energy is required to form the reaction. And about 100 kilojoule per mole energy is liberated. This minus sign which indicate this much amount of energy is released from alkyl chloride and alcohol, so that products can be formed. So free energy of activation is 103, which is plus, and this reaction is energy is minus. जिस किसी रिएक्शन में एनर्जी इज गोइंग टू लिबरेट, so such reactions are termed as exothermic reactions. So SN2 reaction is exothermic, as energy is going to liberate into the system. Energy is going to release from reactants to the environment. So that is called exothermic reaction. उसका उल्टा करो, so to promote the reaction, we have to supply the energy from outside to the system, from atmosphere to the system. So it is termed as this endothermic reaction or endergonic reaction. Exothermic reaction is going to release the energy. Endothermic reaction is going to consume the energy. So this way, in this example, the energy is going to liberate. So, stereochemistry point of view, there is an inversion of configuration. क्या होता है कि OH ने इधर से अटैक किया, पहले तो Cl और दोनों बॉन्ड बन गए at this position, and at this position Cl has departed. Just look like inversion of umbrella. With umbrella in hand, if you are going in the rainy season in the outside atmosphere, because of the wind, if your umbrella is inverse, similar thing is observed here. Consider this as a wind. So it was here, पहले ये दोनों bond hydrogens were here, then they become straight and now they are on opposite side. OH का अटैक हुआ, Cl निकल गया, तो जहां पे दोनों हाइड्रोजन OH की साइड थे, at this position, now they are opposite to OH. So in the products it is different. This is what called as umbrella inversion. It was first identified by a scientist from whose name is Paul Walden. So from his name, this inversion is also termed as Walden inversion. WALDEN inversion or umbrella inversion. So stereo SN2 reaction involves stereo inversion, umbrella inversion और Walden inversion. मानो कि स्टार्टिंग मटेरियल का स्ट्रक्चर कॉन्फ़िगरेशन है कैपिटल R, तो प्रोडक्ट का उल्टा हो जाएगा S. If starting material is levo rotatory, small l, product will become small d, dextrorotatory. So this way, SN2 reaction involves this concept. So we are stopping ourselves up to this one and we'll continue our discussion in the coming slide from this onwards. Thank you all.